After completing this lesson, you will be able to understand bracing, create a framing elevation, create vertical bracing, create horizontal bracing, and understand framing properties. The objective domains covered are 1.1e, work with structural framing and connections. Bracing members are designed to resist lateral loads, typically from wind and seismic forces. Normally a brace is constructed from materials such as steel that can resist both tension and compression. A brace is a specific element inside Revit with a unique set of properties that enables efficient modelling and setting out. You should not use beams to represent bracing. Go ahead and open up the file 010 Work with Structural Framing Part 3. You'll notice that the model opens up in the 3D view. We're going to start by creating some vertical bracing in this area of the structure. To create the vertical bracing, we first must create a framing elevation. The framing elevation will need to be created in a floor plan. In our project browser, let's go ahead and open up the 00 ground floor plan. Let's now zoom up on grid 3, and our framing elevation will elevate all the framing along grid 3. To create the framing elevation, let's click the View ribbon, and then pick the elevation drop-down and select Framing Elevation. You'll now notice that when we hover over a grid line, the framing elevation symbol would attach itself to the grid. Notice as I move my mouse either side of the grid line, the framing elevation will either look outside or inside the structure. On the options bar, Attach to Grid is selected. This is the default option and the one we generally want when we're creating bracing. I'm going to go ahead and place down my framing elevation. You'll now notice in a project browser that a new folder is created, Elevations Framing Elevation. Let's then go ahead and open up Elevation 1A. You'll note that the crop region goes to the full extent of the structure. I'm going to edit that so we can select the crop region and use the segment handle to reduce the height of our crop. We'll then change the scale and our detail level. So I'm now ready to model my vertical bracing. On the Structure ribbon, select Brace. You'll note on the Context ribbon we only have the option of drawing a straight line since this is a tension component. In the Properties palette, click the Type selector and just ensure that our flat bars are selected. When we draw our first element, it's really important that we attach it first to the column and then second to the top of the beam. I can ensure that I'm attaching to the correct elements by keeping an eye on the status bar in the bottom left of Revit. You'll notice now it says nearest to structural framing. I can then go ahead and place this at an arbitrary position. The accuracy of this placement doesn't matter too much at the moment. We'll use the Properties palette to get this into an X-braced configuration. I'll then repeat that on the other side. And there's my bracing placed. What we now need to do is use the Properties palette and the constraints to accurately position our vertical bracing. Let's start with this braced member here. I'm going to expand the Properties palette so we can fully read all of the properties. Let's start here. So you'll note that I have a Start Attachment Level reference. This is attached itself at the minute to the top of foundation. I'm going to change that to ground floor and set my attachment elevation to 0. You'll now notice that the bracing starts at the ground floor level. The end attachment type is currently set to distance, and here we've got roughly 7 feet from the end of the beam to this position here. The end attachment type is presently set to distance. I'm going to change this to ratio. The ratio will range from 0 being the start of the beam and then 1 being the end of the beam. For example, if I type in 0.25 for the ratio, you can see that the brace then snaps a quarter of the way along the beam. In our case here, let's set this to 1. I'll then repeat that for the brace on the other side. So once again, we can set this to the ground floor level. We can set a start attachment elevation to 0, change the distance to ratio, and set the ratio, in this case, to 0. So our bracing is now complete. Let's switch to the 3D view, and we can review our bracing. Now, you will notice here that actually we have a clash between the two braced elements. I'm going to resolve that by offsetting one of these braced elements in the y-axis. I'm going to select this brace here, and notice in our properties we have y offset value. The thickness of the bracing is 3/8 of an inch, so I'm going to offset it 3/8, like so, and you can now see that this member is now in front of this member here. Using a ratio to set out the bracing is a good idea. If the bay changes size, then the bracing would automatically adapt. Next, we create some horizontal bracing on our roof structure. So here, on the roof, we're required to place some circular hollow sections for the roof bracing. On the structure ribbon, let's select Brace. In the Properties palette, in the Type selector, let's ensure that we're using our 3.5-inch round structural tube. On the Options bar, you'll note here that we have 3D snapping enabled. This is quite important. You'll notice as I now move over the frames here, I can snap to these frames in 3 dimensions. So my first brace is going to be attached to this beam here, and then to this beam here. And I'll draw a second braced member across in the opposite direction. So again, we've got an X configuration for our bracing. Let's begin by setting out this braced element here. So when I pick this element, again, we have the same settings in our Properties palette. So you'll note here that we have Start Attachment Type. I'm going to set this to Ratio. And once again, I'll set the ratio to 0. And we'll do the same over here. This is going to be set to a ratio and set that to 0. Now also at this end, we also need to be at 0. And this member's now correctly set out. This member here is going to give us a bit of a problem because actually this beam here is in one length. So in order to set this out, I actually need to know the distance from this point here to this point here. To measure that, I'm going to open up the 5th floor plan. So I can now see my bracing in plan, and I can also see the distance I need to measure. So on the Quick Access toolbar, I'm going to select Measure Between Two References. And I'm going to measure between the centre of this column here and the intersection here of these two beams. If we take a look at our value here, it's approximately 25 foot 2¼ inches. So if I select my brace, in this case I'm clicking it in the plan view, you'll notice here that I can set this distance. Now here I can type in 25 foot and 2¼ inches. Like so, and you can see the brace is now directed to the correct location. However, that is dependent on this end of attachment to reference. Is that reference in the end of the beam or the start of the beam? So we've got to be a bit mindful about that as well. Now something you will notice is that my symbolic line for my bracing is actually off axis. If I select both braced elements, you'll notice here that we have structural usage. I'm going to go ahead and set this to kicker bracing, and you'll now notice the bracing's positioned down on the centre lines. If we go into the 3D view, you can now see our bracing's configured quite nicely in that bay. The last thing to do is perhaps set the Z offset value so the two braces don't clash in the centre of the bay. So I'm going to opt to offset this member down and this member up. So the diameter of our tubing is 3.5 inches. So here you'll note we have our Z offset value. So here I could set this to 1.75 inches and that moves up. And then this one here can be set to negative 1.75 inches. and our bracing now doesn't clash.